Coconut College of Engineering and Technology, Department of EEE, subject code 24EE302, subject name Electron Devices and Circuits. The unit 4 feedback amplifier and oscillators. Basic concept of feedback amplifier. This feedback amplifier is basic concept mixer, basic amplifier with the gain A, sampler and feedback networks. These are all the basic black diagram of feedback amplifier. The output quantity either voltage or current is sampled by a suitable sampler which is of two types, namely voltage sampler and another one is current sampler and to the feedback network. The output of the feedback network, which is a fraction of the output signal, is combined with the external source signal by S through a mixer and fed to the basic amplifier. So the mixer is also known as comparator, is of two types, namely series mixer and shunt mixer. So basic amplifier A, feedback ratio beta, amplifier feedback amplifier gain AF, pi S AC signal in the input side, current or voltage, pi F feedback signal, current or voltage. There are two types of feedback, positive feedback network and negative feedback network. Here positive feedback, if the feedback signal pi F is in phase with the input signal pi S, then the net effect of the feedback will increases the input signal given to the amplifier. The input voltage applied to the basic amplifier is increased, thereby increasing exponentially. So the positive feedback amplifier gain AF is equal to A divided by 1 minus A beta. Hence AF greater than A, the product of the open loop gain and the feedback factor is called loop gain. So here loop gain is equal to A beta. So these are the basic explanation for this positive feedback amplifier circuits. The positive feedback increases the instability of an amplifier, reduces the bandwidth and increases the distortion and noise. So next negative feedback. The negative feedback signal out of phase with the input signal pi S, then pi I is equal to pi S minus pi F. So the input voltage applied to the basic amplifier is decreased and correspondingly the output is decreased. So the negative amplifier gain AF is equal to A divided by 1 plus A beta. The effect of negative feedback. So the effect of negative feedback, stabilization of gain. The stabilization of the gain is equal to DAF divided by AF is equal to DA by A 1 divided by 1 plus A beta. Next one, stability is equal to 1 by 1 plus A beta. Next one, increase the bandwidth. The bandwidth means the difference between upper cutoff frequency minus lower cutoff frequency, that is the cutoff frequencies. So here this cutoff frequency is indicating for this AF into BWF is equal to A into BW, and then bandwidth would be increased by 1 plus A beta. So BWF is equal to, that means bandwidth into 1 plus A beta. So next one, decreased distortion. So decreased distortion DF is equal to D divided by 1 plus A beta. Next one, decreased noise level means NF is equal to N divided by 1 plus A beta. Next one, increasing the input impedance value. So ZIF is equal to ZI into 1 plus A beta. Decreases in output impedance ZIF is equal to same thing of the expressed ZI into 1 plus A beta. So next one, the main thing is consider types of negative feedback connections. The negative feedback connection is classified in 4 categories. voltage series feedback, voltage shunt feedback, current series feedback, and current shunt feedback. So first one, voltage series feedback. So the basic amplifier is given for this A, and then feedback network beta. The output is certain amount is again connected for this input side. The input to the feedback network is in parallel with the output of amplifier. A fraction of the output voltage through the feedback network is applied in series with the input voltage of the amplifier. The shunt connection at the output reduces the output resistance R0. The series connection at the input increases the input resistance. Is also known as series shunt amplifier. So beta is equal to Vf divided by V0. Next one, voltage shunt feedback. So here the shunt derived shunt fed feedback connection. The fraction of the output voltage is supplied in parallel with the input voltage through the feedback network. The basic amplifier with the gain A, and then it will be connected for this feedback network beta. The feedback signal IF is proportional to the output voltage V0, and then this type of amplifier is called trans resistance amplifier or shunt to shunt feedback amplifier. So output resistance of the given value is R0 F parallel RL, that means load resistance. Next one, series current series feedback. Here the current series feedback, a voltage is developed which is proportional to the output current. So this is called current feedback even though it is a voltage that subtract from the input voltage. Because of the series connection at the input and output, the input and output resistance get increased. This type of amplifier is called trans conductance amplifier or series to series feedback amplifier. Next one, voltage gain AF. The voltage gain of the feedback is A is equal to minus HFE RL divided by HIE. Output resistance R0F is equal to 1 by H0B, that means output biasing. Next one, current shunt feedback. So this is called series derived and shunt fed feedback. The shunt connection at the input reduces the input resistance, and the series connection at the output increases the output resistance. This is true current amplifier, also known as shunt series feedback amplifier. Oscillators. Any circuit which is used to generate a periodic voltage without an AC input signal is called a oscillator. To generate the periodic voltage, the circuit is supplied with the energy from DC source. If the output voltage is sine wave function of time, the oscillator is called a sinusoidal or harmonic oscillator. There is another category of oscillator which generate non-sinusoidal waveforms such as square, rectangular, and triangular and sawtooth waveforms. Next one, classification of oscillators according to waveform generator. Sinusoidal oscillator. Second one, relaxation oscillator. Second type, according to fundamental mechanism, negative resistance oscillators and feedback oscillators. Third one, according to the frequency generated, audio frequency oscillator, radio frequency oscillator, very high frequency oscillator, ultra high frequency oscillator, and microwave frequency oscillators. Then fourth classification, according to the type of circuit used in sine wave, LC tuned oscillator and RC phase shift oscillator. Next one, Hartley oscillator detailed. Here this given circuit diagram is known as Hartley oscillator. Z1 and Z2 are inductor, and connected to the Z3 is a capacitor. Resistors R1 and R2 and RE provide the necessary DC bias to the transistor because the transistor Q symbol is connected. The CC1 and CC2 are the coupling capacitor. The feedback network consisting of inductors L1 and L2, and the capacitor C determine the frequency of the oscillator. The common emitter mode of the transistor provide the phase shift difference of 180 degree between the input and output. Therefore, the total phase shift is 360 degree. So F0 is equal to 1 divided by 2 pi root of LC. L is equal to L1 plus L2 plus 2M. So the condition for sustained oscillation HFE greater than or equal to L1 plus M divided by L2 plus M. So analysis: Z1 and Z2 are inductive reactants and Z3 is the capacitive reactants. So we can derive the impedance value for given circuit, and finally we can get the frequency output is equal to 1 divided by 2 pi root of L1 plus L2 plus 2M into C. So the final equation HF is equal to L1 plus M divided by L2 plus M. This is operation of the Hartley oscillator. So next one, Colpitts oscillator. The Colpitts oscillator shown in the given figure. The Z1 and Z2 are capacitors and Z3 is an inductor. The resistors R1 and R2 and Re provide the necessary DC bias to the given circuits. So the operation of the given Colpitts oscillator is mentioned for this in this explanation. For the damped harmonics oscillator are set up in this given circuit. The oscillatory current in the tank circuit produce AC voltages across C1 and C2. As terminal 3 is earthed, it is at zero potential. The phase difference between the terminals 1 and 2 is always 180 degree. Therefore, the total phase shift is 360 degree. If the feedback is adjusted so that the loop gain A beta is equal to 1. So the analysis of the given circuit frequency of oscillation F0 is equal to 1 divided by 2 pi root of LC. So the final one, F0 is equal to 1 by 2 pi into root of C1 plus C2 divided by LC1 C2. Next, RC oscillators. So RC phase shift oscillators and Wien bridge oscillators. So RC phase shift oscillator using cascader connection of high pass filter and also using for this low pass filters. So next one, Wien bridge oscillator. The Wien bridge oscillator is used for two-stage RC coupled amplifier, which provide the phase difference phase shift from 360 degree. A balanced bridge is used as the feedback network, which has no need to provide any additional phase shift. So here this lag lead network is used for these four types of arm. The arm A to B connected for this resistance and capacitance connected in series connection. Similarly, B to C is connected for this resistance and capacitance connected in parallel connection. Similarly, R3 and R4 are individual resistance connected in this given circuit. Here Q1 and Q2 two transistor is connected. Connected. The coupling capacitor CC1 and CC2 connected for this output. So final equation we can get the output frequency 1 by 2 pi RC if the resistance and the capacitance we can choosing for the commonly. So this Wien bridge oscillator derivation, so we can find out these feedback, that means amplifier gain of the amplifier, and then using for this S equal to j omega 0, F0 is equal to 1 by 2 pi RC, so omega 0 is equal to 1 by RC. Next one, crystal oscillator. The crystal oscillator is inductor replaced by the crystal. So the piezoelectric crystal, usually quartz, which is used as a resonant circuit replacing an LC circuit. So C1 and C2, the crystal is used. So quartz crystal